Okay, here we go. Monday, that's the 22nd, and we're watching a video where we are graphing rational expressions again. The word ratio reminds you that a rational expression is a ratio or a fraction. It has an algebraic expression in the numerator and in the denominator. So that's a rational expression. This time it's case 2, where the degree of the numerator equals the degree of denominator. So, case 1, you'll recall the degree of the numerator was less than the degree of the denominator. The degree is the exponent of the greatest exponent in the numerator, which is 1, and the greatest exponent in the denominator is 1. So they have the same. The degree of the numerator is equal the degree of the denominator, so we are clearly in case 2. To graph case 2, we're going to do va-ha, va-ha-ha, va-ha, and then we're going to zero out x, zero out y, and look for a very large number, 10. In rational expressions land, 10 is a very large number. So that will give us our starting point. So a lot of this is repetitious to how we graphed case 1. First of all, the vertical asymptote is what will cause the denominator to be 0, which is an impossibility, so we will exclude that with those values with an asymptote. And we see at x equals 0, that will have to be excluded. So that's the vertical line right on. So I'm going to put an asymptote right on the y-axis. Then the difference from case 1 is right here. So in case 1, it was always the horizontal asymptote was always the x-axis. But today it's going to be found in case 2 a different way. And the way it is found is the lead coefficient in the numerator divided by the lead coefficient in the denominator. Y equals, the lead coefficient is 2, so that's the number in front of the term with the highest power in the exponent of the variable. So here's the variable, the highest power is 1, its coefficient is 2, divided by the coefficient of the lead term in the denominator, which is 1. 2 divided by 1 is 2. So we have a horizontal asymptote at y equals 2. And that's the basic difference between the two cases, is right there. Then you put in 0 for x. You put 0 here. Let me rewrite this. It's kind of jumbled up. When I put a 0 for x, this becomes 0, this becomes 0. Uh-oh. We cannot have, it won't be, that's an impossibility, so we will have no value for y. So there's no place that this will cross the y-axis. Then, let's see if it's a place where it crosses the x-axis. We zero out y, so we're thinking 0 equals 2x minus 1. If we multiply both sides by x, this disappears. And x times 0 is 0. So it ends up whatever makes the numerator 0. So setting that equal to 0, move the 1 to the other side, divide by 2, we get x is 1/2. So 1/2 in the x direction. So it's going to cross there. So now all we need is a starting point. And we're aware that rational expressions are often slash slash. So it's either slash slash or slash slash. So we're aware of that pattern, so we're expecting it here, especially when there's only one vertical and one horizontal asymptote. Let's see if we can find our slashes. We want a starting point, so I like to put in a large number. In ratio, rational expressions land, 10 is a large number. So when I put a 10 in here, I get 20 minus 1 is 19 over 10. So that's 1.9. So it's just under, so way down here at x equals 10, and I won't even really get there. I'm going to be very close, but just under this line, y equals 2. So it's going to start on this side, the lower side of this asymptote, hit this point, and bend down, cannot cross this vertical asymptote. Then, rule of asymptote jumps up and goes like that. So you'll see the slash slash pattern. Alright, so I think I'll just do one other today. So that was the first one, y equals 2x minus 1 over x. Alright, the second one, we'll just add a complication in that you will see something that, like you saw yesterday, or last video, whenever you watched it. Alright, is this case 2? Clearly it's case 2, because the degree of the numerator, 2, is equal to the degree of the denominator, 2. So, we know everything's going to be the same, ha 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 ha, except the ha part. I'm going to zero out x and find y, zero out y and find x, and find a starting point at 10. So the vertical one, let's factor the top and the bottom so we can see a little clearer what's going on. This is a difference of 2 squares. It factors x minus 3, x plus 3. And then this factors x minus 3, x plus 1. So we talked about this last night. So we know that that creates a hole in the bottom of the C. So at x equals 3, I'm going to put a wiggly line to remind myself that there's a zero, not a zero, but a hole. Whenever the graph crosses there, I got to remember to put a hole. That's my little reminder. Alright, so we're ignoring that. It's not going to be a zero. It's not going to be an asymptote. It's going to be a hole. So let's continue. Let's say when x is 0, it's probably easier to put x is 0 into this form. These are equivalent. Use the one that works the quickest. So when I put x is 0, I get minus 9 over minus 3, which is positive 3. So I quickly identified a point, 0, 3. It's got to cross there. And then when I zero out y, remember the denominator won't count, so I'm going to use this form. And I know that x minus 3 is not a 0, and it's not an asymptote, so I'll ignore that. But x, what would cause this y to be 0? X equals minus 3. So I'm going to do minus 3, 0. Right there. And give myself a good starting point. I like this form. So I get 10 minus 3 is 7 times 10 plus 3, which is 13, divided by 10 minus 3, which is 7, 10 plus 1, which is 11. So it ends up being a little bit greater, something like 13 over 11, which is greater than 1. So, but not by a whole lot. Oh, I forgot my ha. That's the important part. So my horizontal asymptote is going to be the lead coefficient in the numerator divided by the lead coefficient in the denominator. So we have y equals 1, and the vertical asymptote is what causes this to zero out, x equals -1. So recommend you do that first, not last. So we have x equals -1 is the ba, and the ha is y equals 1. Now the starting point is a little greater than 1, so this is y equals 1. So way down here we're going to be just above this asymptote. So I'm going to start here, and I'm going to go all the way over to this 0 and that asymptote. So I'm going to bend like this. There's my slash. Except right here, as I promised, that little wiggly line would remind me that there's a hole right there. And then when I jump asymptotes, I come back down. I'm going to hit this and become asymptotic to that. So I was going up, I jump the asymptote, I start down. Alright, so that's my graph. Alright, hopefully you will be a master on case 2. So with that thought in mind, carry on.